Hi, I'm Bob. We will continue our solutions to the last 8 exercises today. Let's see exercise 3.10. The last of California's operating gold mines closed after World War II because mining had become unprofitable when the price of gold was $34.71 an ounce, about $446 in current dollars. However, in 2012, the price of gold approached historic highs, hovering around $1,700 an ounce. Consequently, in 2012 and 2013, several large-scale hard rock gold mining operations reopened for the first time in more than half a century. In Part A, show in a figure what this information implies about the shape of the gold extraction cost function. A competitive firm shuts down only if the market price is less than the minimum of its average variable cost. According to this shutdown rule, when the last gold mine closed, the market price of gold, $446 an ounce, must be less than the firm's minimum average variable cost. It is the shutdown point A in the graph where the marginal cost curve cuts the average variable cost curve at its minimum. When the gold mine reopened, it must start to make a positive profit. So the reopening point is B, where the firm's marginal cost curve cuts the average cost curve at its minimum. In Part B, use the cost function you drew in Part A to show how an increase in the market price of gold affects the amount of gold that a competitive firm extracts. Show the change in the firm's equilibrium profit. A competitive firm maximizes its profit by producing output Q where its marginal cost equals the market price. Its supply curve is the marginal cost curve above its minimum average variable cost. The supply curve is upward sloping. As market price increases, the firm extracts more gold. The firm's profit increases by the blue area as the market price rises from 1,700 to P in the graph. Let's jump to exercise 3.11. If a competitive firm's cost function is as follows, where A, B, C, and D are constants, what's the firm's marginal cost function? What is the firm's profit maximizing condition? The marginal cost function is as follows. The firm's profit maximizing condition is the market price equals the firm's marginal cost. This is the first-order condition for profit maximum. The profit maximizing output should also satisfy the second-order condition for local maximum. That is, the slope of the marginal cost curve at the profit maximizing output is positive. You can review the details of it in exercise 3.1. Let's find answers to exercise 3.12. A Christmas tree seller has a cost function as follows, where PT equals $11.5 is the wholesale price of each tree, and T equals $2 is the shipping price per tree. What is the seller's marginal cost function? What is the shutdown price? What is the seller's short-run supply function? If the seller's supply curve is S, what is partial S divided by partial T? Evaluated at PT equals $11.5 and T equals $2. We first find the firm's marginal cost function. Then we find the shutdown price. The shutdown price equals the minimum average variable cost. The marginal cost curve cuts the average variable cost curve at its minimum, so we can obtain the minimum average variable cost by equating the marginal cost and the average variable cost functions. We have Q equals 0, and the shutdown price is around 14.08. The marginal cost curve is always above the average variable cost curve for all positive output. Next, the short-run supply curve is the firm's marginal cost curve above the minimum of its average variable cost. It is identical to the marginal cost curve in this case. Finally, we examine how the supply changes with the shipping price. The equation is not clear. If we want to know how the price changes with the shipping price, the partial P over partial T is 1. The price increases by the same amount of the change in shipping price. If we want to know how the output changes with the shipping price, we can derive the change in supply quantity with respect to the shipping price. We write Q in terms of P and T, and then take the derivative of Q with respect to T. The quantity supplied decreases as the shipping price increases. Let's solve exercise 3.13. Many marginal cost curves are U-shaped. Consequently, the marginal cost curve can equal the price at two output levels, which is the profit maximizing output Y. It is the same question as exercise 3.1. At the profit maximizing output, the marginal cost curve is upward sloping. The slope of the marginal cost curve at that output is positive. Let's go to exercise 3.14. Each of the 10 firms in the competitive market has a cost function of C equals 25 plus Q squared. The market demand function is Q equals 120 minus P. Determine the equilibrium price quantity per firm and market quantity. The market supply is the horizontal sum of each firm's supply. We solve the problem in 4 steps. First, we find each firm's supply function. It is the firm's marginal cost function above the minimum of average variable cost. Using the cost function, we derive the firm's marginal cost function and average variable cost function. The firm's marginal cost curve is always above the average variable cost curve for all positive output. So each firm's inverse supply function is P equals 2 times Q. The firm's supply function is Q equals P over 2. In the second step, we find the market supply function. The market supply is the horizontal sum of each firm's supply. Q equals 5 times P. In the third step, we find the market equilibrium price and quantity. Combining the market supply function with the market demand function gives the market equilibrium price of 20 and the market equilibrium quantity of 100. In the last step, we find each firm's quantity of output. It is 100 divided by the 10 firms, which equals 10. Or we can use the firm supply function. It gives the same result. Let's solve exercise 3.15. Given the information in the previous exercise, what effect does a specific tax of $2.4 per unit have on the equilibrium price and quantities? The cost function becomes C equals 25 plus Q squared plus T times Q after the specific tax of T is imposed on the firm. We follow the same steps as in the last exercise to find the market equilibrium price and quantity and each firm's quantity of output. They are functions of T. If T equals 2.4, then the market equilibrium supply is 98. The market equilibrium price is 22, and each firm's supply is 9.8. Let's do exercise 3.16. Since 2013, most customers at California grocery and drug stores must pay an extra 10 cents for each paper bag that the store provides. Does such a charge affect the marginal cost of any particular good? If so, by how much? Is this fee likely to affect the overall amount that customers pay for groceries? If the paper bags go with the goods and medicine, customers have to pay for them. The firm's marginal cost and the average cost fall by 10 cents. The firm's supply increases from Q1 to Q2. The customers pay more in the short run, but in the long run, as the market supply exceeds the market demand, the market price falls, and at the new equilibrium, the customers will not pay more for groceries. The analysis is based on paper bags are mandatory. If paper bags are optional, the customers can choose not to buy them, and the effect on the firm's cost is negligible. Let's finish exercise 3.17. A firm has a cost function as follows. The firm is a price taker and faces a market price of 250. What is its profit function? What quantity maximizes its profit? What is its profit? Should the firm operate or shut down? The firm's profit function, pi, is as follows. The first order condition for profit maximization is the derivative of profit with respect to output equals 0. It leads to a quadratic equation. Using the quadratic formula, we obtain the two possible solutions. One is 20 and the other is 4. At an output of 20, the profit is 600, and an output of 4, the profit is negative. So the profit maximizing output is 20. The firm's profit is 600. The firm is making a positive economic profit. It should operate. We can also use the result from exercise 3.1 to find which of the two possible solutions is the profit maximizing output. The slope of the marginal cost curve at that output should be positive. Only when the output is 20 is the slope positive. Thank you so much for answering all the questions with me today. See you tomorrow for more exercises. Goodbye. Thank you for watching this video and subscribing to my YouTube channel. See you next time.